the previous discussion had just had us going from an equation to a graph. But suppose I want to do that differently, and I want to go from a graph to an equation. Okay. Now, suppose I've got a graph that looks like that. Well, I know that it's going back and forth between plus and negative 10 centimeters. So, from doing that, I can look at this and say, okay, I want this function to map onto that form. How can I do that? Okay, I've already got one step. X as a function of t is equal to 10 centimeters times the cosine of omega t plus phi. Now, let's see, the next thing I want to do is I want to find out that phase constant. To find the phase constant, I look at what this equation, what the equation's at 0. Because if I look at that at 0, then I should have x at 0 is equal to a times the cosine of simply the phase constant. Or 5 centimeters is equal to 10 centimeters times the cosine of the phase constant, or .500. Now notice, I just divided 5 centimeters by 10 centimeters. So 5 centimeters divided by 10 centimeters is 0.5, no units. The units have just canceled out. And that's equal to the cosine of phi naught. Or that phase constant is the inverse cosine of 0.5, or that's 1.047, intermediate step. I'm going to keep one extra sig fig for the moment. Radians, which is to 3 significant figures. So, I mean, really, if I'm writing this out as an equation, I should probably write 1.05 radians right here. It's really close to pi over 3. So suppose this then, we notice, that peaks off at like 1 second. And that turns out to be 4 seconds. 7 seconds. 10 seconds, and so on. I can look at this and say, okay, the period is the time between two identical locations. And that's not just the object being in the same place, but in the same place going in the same direction. So, this represents one full oscillation. That represents one full oscillation. But I've got an easy way to measure that here. That is, hey, to our closest ability to eyeball that, 6 seconds. So the period is equal to 6 seconds. The frequency is 1/6 hertz, which is 0.1 6 7 hertz, and the angular frequency is 2 pi times that, which is 1.05 radians per second, which is really close to, as this turns out, 2 pi over 6 is pi over 3. So write this out in this sense from those numbers that I grabbed. Then this equation written as completely as possible as the position as a function of time is equal to 10 centimeters times the cosine of, I should technically use the numbers here. If you punch this in, it'll use the numbers, but it's really close to the cosine of pi over 3t plus pi over 3.